Hello, Algebra 2. Here we are with rational exponents. Alright, rational means you can write it as a fraction. So if I have w to the x over y power, we're going to have fractions in the exponent. That big capital W, that's your base. The top part of the fraction of your exponent is your power, and the bottom number is your root, which should be pretty similar to stuff we've already done, where we've reduced these roots, and we always do exponent divided by root. So if we're going to go from exponent form to radical form, we have x to the 2/5, so that's the second power, squared, but then fifth root. So I'm going to write that with a fifth root of x squared, or you could also think of it as the fifth root of x squared. Okay, if I'm just changing forms, if that's the type of problem it is, where I'm just changing forms, I'm probably going to write it like this. If it's a problem that I'm actually doing or solving, evaluating, I'm probably going to do it like this. I'm going to do the fifth root of x and then square it. And we'll talk about that in a minute. Okay, let's have you pause and try this one. Alright, we got the seventh root of x to the third, or you could have the seventh root of x to the third. Okay, reverse. Now we have radical form. We're going to turn it into exponent form. Exponent, or power, over root. We're going to have x to the 1/4 power. Go ahead and think about this one. Okay, fifth root of x to the third. We're going to have x to the third power over the fifth root. X to the 3/5 power. Okay, kind of back to the top one, where we talked about how you could write it in two different ways. Okay, and I said that if I was just doing a conversion problem where you just need to switch forms, I'm probably going to write it like this. But if I'm actually solving it or evaluating it, I'm going to write it like that. Because it's easier, you have a better chance of being able to do it in your brain if you make it smaller first and then bigger. Okay, and doing it in your brain is going to be quicker than getting out your calculator and typing stuff in. Okay, if we were to go this way and do 216 squared, 216 squared is going to be 46,656. And that is going to be pretty difficult for you to evaluate the cube root of. You would have to use your calculator. Okay? So where can I get the cube root button? Okay, it's going to be under math. And we're going to go down to the fourth thing. And it should give you a little cube root, and you can type in 46,656. And we'll see that that is 36. If you had something bigger than a cube root, like a fifth root, okay, if you have this kind of calculator, we can go math and down to x root, and then it just gives you the empty template. And you can type whatever root number you want on the top, and then whatever you're trying to do on the bottom. If you're using a black and white calculator, or I'm going to call it the fat calculator because it has to have like the batteries in there, you have to have the root number you want typed in first. So if I want to do the fifth root, I have to have the 5 typed in first, then math, then down to x root, and then it will bump it up there, or some of them don't even bump it up there that way. It'll just leave the 5x and then have x root, and then you can type in the number. Okay? Alright. But if we went this way, we're going to be doing enough of the cube roots here that I think you could probably guess that the cube root of 216 is 6. And then you could do 6 squared is 36. Much quicker. Okay, and if you didn't, again, we could go to math and do a cube root of 216. Oh, it's 6, and then I can do 6 squared, 36. Whereas this way you would have had to have done the calculator for both steps. Okay, so I like to make them smaller first, using brain power, and then do the power. What else do we have with this one? Ooh, a negative exponent. Okay, so before we do 81 to the negative 1/4, let's think about what, like 5 to the negative 1/1, or the negative 1 exponent is. Okay, a negative exponent just is the reciprocal, it flips it. So 5 to the negative 1 power would be the same as 1 over 5 to the positive 1st power. It just flips your exponent upside down. Okay, so power over root. I'm going to do the 4th root of 81, and then to the negative 1 power. Okay, 4th root of 81, you can do it, brain power. It's going to be 3, and then 3 to the negative 1 power is 1 over 3. Alright, so if you push pause and try 32 to the negative 1/5 power. Alright, 32 to the negative 1/5 power. I'm going to do the 5th root of 32, and then we're going to do negative 1, which is basically going to flip it. So the 5th root of 32 is 2, and then negative 1 power is 1 over 2. Alright, more fun. 256 to the 3/8 power. Okay, root first, so 256 to the 8th power, and then we'll cube it. Before you reach for your calculator, you could probably guess. 8th root is pretty big for this to only be 256. If you're guessing 2, you are right. Okay, we just saw over here that 32 is the 5th power of 2. So times 2 again, that'll be the 6th, that's 64. Times 2 again is the 7th, 128. Times 2 again, the 8th power is going to be 256. So this is just 2 to the 3rd, which is 8. Okay, let's have you try that one. Okay, we're going to do the 4th root of 81, and then we're going to cube it. Okay, 4th root of 81 is 3. And then 3 to the 3rd power, 3 times 3 is 9, times 3 a 3rd time is 27. Alright, yesterday we revisited, if you were doing a division problem, and we had like x to the 6th over x to the 4th, something like that. Division, we get to subtract our exponents. Well, if we're subtracting exponents with division, what are we going to do with multiplication of the two same base numbers here? We're going to get to add our exponents. And 3/7 plus 2/7 is going to give us x to the 5/7. Okay, over here, let's have you try this one. But be ready, be careful, be on the lookout. You might have to reduce some fractions. Okay, 1/6 plus 2/6 is 3 over 6, which would reduce to y to the 1/2 power. More exponent fun. Parentheses to a power. Okay, when there's just multiplication or division going on inside parentheses and then we have a power, that power goes directly to everything. Okay, if we had like x plus 2 squared, alright, we found out earlier this year that it is not just x squared and 2 squared. There's stuff in the middle. Okay, but this does not have a plus or a minus in the middle, so it is just going to go directly to it. So we are doing 3 squared, and then how do I square this? Power, parentheses, power, we multiply. And we're actually kind of multiplying here too, because it's 3 to the 1st power. So we're going to multiply those exponents. We'll have 3 squared and x to the 2/3 power. 3 squared is 9, and that one's still going to be 2/3. Okay? Again, I'm going to recommend putting a little 1 up there. And you are going to multiply those powers. Ready, set, go. Okay. 2 to the 4th power, y to the 4/5. And 2 to the 4th, we have 2, 4, 8, 16. 16, y to the 4/5 power. Sometimes we have to rewrite numbers as powers of a lower number. This one was a perfect cube, so this is actually like from 2 days ago. Cube root of 64 is 4. And then power divided by root, z to the 6th cube root. 6 divided by 3 will have z squared. Okay, this got a star problem. It's a little bit tricky. 4th root of 27. Okay, it's not going to work out very clean, but we are going to look at this number that's with it, the small number with it, 3. That's kind of the hint. Can I rewrite 27 as a 3? So this is the 4th root of 3 to the 3rd power over the square root of 3 to the 1st power. Okay, now we're going to switch it from radical form to exponent form, rational exponents. Power divided by root, so we have 3 to the 3/4 over 1st power, 2nd root. Okay, and then from our stuff on yesterday, we know we can subtract. We can subtract. What's 3/4 minus 1/2? Okay, got to get a common denominator. 1/2 would change to 2/4. And 3/4 minus 2/4 is 1/4. So we would have 3 to the 1/4 power, or take it all the way back, because the problem did start in root form or radical form. Take it all the way back to radical form. It is the 4th root of 3. Alright, that was a crazy one. There's a lot of thinking on that one. Okay, a lot of stuff here with exponent properties and with fractions in the exponent. Okay, check out the worksheet there and compare your work with the answer key. See how you're doing. If you have any questions, let me know. Thanks a lot, guys. Good luck.